Here's an explanation for Hailey's algebra problem. The first thing that I did is I tried to solve each expression for one variable. So on the first one, if you take b away from both sides, you have a equals 11 minus b. I'm going to solve the second one also for a. If we take c away from both sides, we have 10 minus c. The next one I'm going to solve for b. If we take d away from both sides, we have 7 minus d. And the last one I'm going to solve for c. If we add d to both sides, we get 1 plus d, or d plus 1. What I'm going to do next is use this top equation right here, and I'm going to substitute for values of a and b from my other equations. And here's what I mean. According to this second equation, a is equal to 10 minus c, so I can substitute 10 minus c for a. If I rewrite that, then I have a, 10 minus c, is equal to 11 minus b, but I'm going to substitute 7 minus d for b. So 10 minus c, a, equals 11 minus b, which is 7 minus d. Now notice I put that in parentheses because you are going to need to distribute this subtraction to everything in the parentheses, because this right here is equal to b. However, so far we still have an equation that has two different variables, and our goal is to get an equation with just one variable. So what I'm going to do is I'm going to take c, and I'm going to look up here and I'm going to substitute 1 plus d for c. So now when I rewrite this, this becomes c, which is 1 plus d, and then just rewrite everything else on the other side. Now I'm going to simplify this equation by distributing. So I have 10 minus 1 minus d, and the reason for that is this is distributed to the 1 and to the d, equals 11 minus 7 plus d. And again, this subtraction is distributed to the d. A negative times a negative is a positive. If we continue to simplify, we have 9 minus d equals 4 plus d. I'm going to move this up to the top here so I have some more room. 9 minus d equals 4 plus d. If I now subtract 4 from both sides, that cancels out over here, and we have 5 minus d equals d. Now I can add d to both sides, and we have 5 equals 2 d's, because this cancels out. And if we solve for d, we can divide by 2 on both sides. That gives us d equals 5 halves, or 2 1/2. Once we've decided that d is 2 1/2, then we can just plug things into our equation. So what number minus 2 1/2 equals 1? That would be 3 1/2. What number plus 2 1/2 equals 7? That would be 4 1/2. And we know that c is 3 1/2, so what number plus 3 1/2 equals 10? That would be 6 1/2. And lastly, let's check to make sure 6 1/2a plus 4 1/2b equals 11, and we can confirm that it does.